Hello all, welcome to this lecture on Elements of Mechanical Engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. In this video, we are going to learn what are the working of a boiler. In the previous lecture, we have seen the basic introduction to a boiler, how a boiler is classified based on different properties. And also we have seen the working of a simple vertical boiler. In this lecture, we are going to see some more examples of boilers and their working. So in this diagram, we can see this is a Cochrane boiler. This is a simple vertical boiler. So let us see the working of this simple vertical boiler. Simple vertical boiler. Now in this diagram we can see that we have different parts. There are different parts that are attached to the different parts of the boiler. So we'll try to understand what is the function of each part and we'll try to understand the working of the boiler, entire boiler. Okay. Now we'll start from the bottom where we have ash pit. Here we have ash pit. Ash pit is nothing but it is a chamber where the ash that is generated while the combustion of the coal is collected. Okay. And on the either sides we have air. This is where the air will be entering into the boiler combustion chamber because we need air for the combustion of the coal. Okay. So this entire thing, this is filled with coal. Okay. Now on above that, we can see here, this is crown furnace grate. So what is crown furnace grate? So this is the place where the coal is taken and it is burnt. So the burning of the coal will be happening in this area. So in the furnace. And also other devices we have on the left side. So this is blow off valve. So what is blow off valve? So whenever there is more pressure inside the cylinder, inside the closed chamber where we are burning the coal, because of the burning, hot gases will be emitting and these gases will contain more pressure. So whenever the pressure is very high, so we will open this blow off valve so that high pressure will be released. Okay. So this is for removing the hot gases sometimes when the pressure is very high. And above that we have feed check valve. Feed check valve is nothing but what do we call feed here? So the water entering into the tank, so that is called as feed. So in the boiler we will be generating steam for which we need water. So the water will be fed into the tank. Okay. So this feed check valve will check whether the water is entering into the tank or not, and it will be operated by a human being or a person so that water will be entering into the boiler. Okay. So when we open this, water will come out or we can push the water inside. And above that we have flue pipe. So what is a flue pipe? So flue pipe is a device which the hot gases that are generated from the combustion of the coal will be entering. Okay, flue pipe. Inside the flue pipe, we have hot gases that are emitted from the combustion of the coal. Okay, and above that, we have brick wall. So this green color lining is called brick wall. This is to protect the boiler structure, or it will insulate the boiler structure from losing the temperature. So what happens if everything is done in an open atmospheric condition? So the heat generated from the hot gases coming out of the combustion of the coal will be left into the atmosphere. But we cannot waste the energy. So we have insulation around the boiler with the help of masonry bricks. We know masonry bricks. So these masonry bricks are the one which will insulate the hot gases that are generated inside the closed chamber. So these hot gases, when they will come in contact with the water will be heated and it is converted into steam. Now after that we have fire tubes here. So what is a fire tube? Fire tube is nothing but it is a tube where the hot gases will be flowing inside. Okay. See here, this is an example of a fire tube boiler. Yesterday or in the previous lecture, we have seen the different classifications of boilers based on the tubes in which the hot gases or water flowing. Okay. There are two types based on the pipes, that is fire tube boiler, fire tube, and water tube boiler. So in fire tube boiler, what happens is the fire will be that means it is not fire. The hot gas is coming out of the combustion will be entering into the pipes, and these pipes are placed inside the water. Like inside the water tank, these pipes are arranged. Just like this, we can see in this picture. So this is all water. This blue color part is all water. Okay, this is all water. Inside we have pipes. So these are the pipes in which the hot gases will be flowing. So this is fire tube boiler. And then we have fusible plug here. So fusible plug is nothing but it is a safety valve which will protect the entire thing. Like when the pressure is too high, the fusible plug can be removed and the pressure can be reduced. Or sometimes it will be operated automatically, like just like when we want to remove excess pressure, we will remove this fusible plug. Okay, and above that we have water level indicator. So this water level indicator will indicate the level of water present inside the boiler. Because we are producing steam with boiler, we should always know what is the level of water present inside the boiler. Because every time we cannot go inside or open the boiler to see what the water level. So we have a water level indicator which will indicate the level of water in the tank that is present inside the boiler. And above that we have a manhole. So what is this manhole? The purpose of the manhole is to accessibility. A person can go inside the boiler chamber and he can do some maintenance works like cleaning the inner surface of the tank, or he can do many other operations. Okay, so this manhole is for accessibility and maintenance. And we have pressure gauge here. So in this picture, if we carefully observe, so the water after heating, it is converted into steam. Now this is steam. This is water. Now the water, when it is converted into steam, the steam will be stored inside a closed container. Like this is a closed hemispherical chamber. In this chamber, the steam will be collected and it is stored. Now, we should know, because the steam that is freshly generated will have more pressure. Because of the increase in pressure and temperature, steam formation will be done. So, we should know how much pressure that is present inside the steam. Okay, so we should know the steam pressure. That is why we have connected a pressure gauge. And after that, we have a safety valve. Now, this safety valve is placed here for the safety. When the steam pressure is very high, it should not blow off the entire boiler structure. Okay, this is just like the weight that is kept in household rice cooker. Okay, so in pressure cooker, what we do is when the pressure is high enough, the pressure will be released by lifting the dead weight. Okay, so similarly, we will have a safety valve here. This safety valve will be raised when the pressure is too high inside the steam container. Okay, and then we have stop valve. Now the stop valve is the one which is operated for removing the steam from the steam container. Okay, so the ultimate purpose of this boiler is to generate steam. The steam that is generated, it has to be taken out. Okay, now the stop valve is the one which is operated to take the steam outside the boiler structure. And on the right side we have chimney. So chimney is the long cylindrical structure which is open to atmosphere, and this is used to remove the hot gases. So what are the gases that are generated while the combustion of the coal? They will get in contact with water, and after losing their temperature, some carbon dioxide and other gases, carbon monoxide. So these gases, after filtration, they will be left into the atmosphere. So here we have a device called smoke box. So what is the function of smoke box? Smoke box is the device. So this is the smoke box. So because the combustion of coal will produce harmful gases like carbon dioxide and carbon monoxide and other components of carbon. So that is why these gases are to be filtered. So the function of this smoke box is to filter those hot gases. After the boiling of the water is done, these gases will come into the smoke box where they will be filtered, and from there they will be let into the atmosphere. Okay. Now, after going into the atmosphere, the harmfulness of these gases are reduced so to a very high level, like they are no longer problematic to the atmosphere. So then the hot gases will be sent outside into the atmosphere. Okay. So these are all the parts of the boiler. We have seen all the parts starting from bottom to the top, and we have brick lining. This is a fire tube boiler where the hot gases will be flowing inside a tube where the tube is placed inside the hot water. Now we'll see the basic working of this boiler. So when coal is taken here and it is burned with the help of air, hot gases will be emitted. So these hot gases, by opening this valve, there is a gate here. By opening this, we will allow these hot gases enter into this chamber. So the hot gases will come here. Okay. From here, they will enter into the fire tubes. So these are all the fire tubes where the hot gases will flow into the fire tubes. So what happens is, on the other side, the hot gases will come out into the smoke box. Okay. So this is a normal procedure. So these fire tubes, these are not small. They are of very large length, like 5 to 6 meters of length. The tubes are there. So whenever the hot gases are flowing through the tubes, the water around the tubes will be heated. So the water will boil and this water will be converted into steam. Now, whatever the steam that is generated, it is collected in this area. This is where the steam is collected. So the steam can be used for any other applications. Okay. So this is the function, and whatever the hot gases are there here, these gases are collected in the smoke box. After filtration, they will be led into the atmosphere. So this is the working of a simple vertical boiler. Now we'll see what are the features of a Wilcox boiler. Okay, so it is a vertical boiler. So far we have seen this is the Wilcox boiler. The name of this boiler is Babcock and Wilcox boiler. So this boiler is vertical in structure and it is multi-tubular, where in this diagram we can see there are multiple tubes. 5 tubes are there. So this is a multi-tube boiler and it is internally fired, which means the carbon, the coal which is taken as a charge, this charge will be combusted inside a closed chamber. And then this is a natural convection process. So if we see here, we have water inside a closed tank. We are not moving that water anywhere. We are not pumping the water into any kind of tube or pipe. So this comes under a natural convection water tube boiler. Sorry, the fire tube boiler. So the water is not forced into anywhere. Okay, so this is a fire tube boiler because the hot gases are flowing inside the tubes. So it is a fire tube boiler, and this is also a low pressure boiler. So it can produce the steam up to a pressure of 15 bars, and the capacity of this boiler is 4000 kg per hour. So per 1 hour it can produce 4000 kilograms of steam. Okay, so these are the features of this boiler, and some more features are there. It is an improved type of simple vertical boiler. So in the previous lecture we have seen the working of a simple vertical boiler. So this is the advanced structure when compared to the simple vertical boiler. So we have modified some options. In simple vertical boiler, there is only one tube, which is a water tube in which the water will be flowing. Here we have a closed water tank inside which we have fire tubes. So that is a modified version. So, and this is an improved vertical type boiler. And after that, it consists of an external cylindrical shell and firebox. So these are the extra advanced features that are added to the boiler for better working and improving the efficiency. We have a smoke box or firebox. So the function of this firebox is to reduce the harmfulness of the gases that are released from the coal. And this has an external cylindrical shell. So you can see in this diagram, this has a cylindrical shell. Okay. Even inside the cylindrical shell, we have brick lining, which will insulate the hot gases. Okay. And then the next one is shell and firebox, both are hemispherical in shape. So in this diagram, we can see the container which is used to collect the steam. This is hemispherical in shape. Now, because of this shape, it has more strength when compared to a rectangular or a square box. Okay. It has more strength to withstand the steam pressure. More the pressure, more the weight that is kept on the inside of this hemispherical wall. So that is why it can bear more pressure. That is why it is designed in this hemispherical shape. And then hemispherical shape gives maximum space and also strength to withstand the pressure inside the boiler. So the steam that is generated will have more pressure. Because of this hemispherical shape, it can withstand more pressure and also it can hold more quantity of steam. And next point is, flue gases from the combustion chamber flow to the smoke box through a number of smoke tubes. So the hot gases, after they get in contact with the water, they will be sent into the smoke box, where they are sent into multiple tubes of smoke tubes where they will be filtered. And the combustion chamber is lined with fire bricks on the shell side. So we have seen this. The brick lining is given inside the boiler, in order to insulate the hot gases escaping into the atmosphere. So this is the working of Babcock and Wilcox boiler. So these Babcock and Wilcox are the names of the scientists or a person who developed this kind of boiler. And then we'll see the working of another type of boiler. So that is Lancashire boiler. Lancashire boiler. So this is a horizontal boiler where we'll see the working. So we have different diagrams here. This is front view, this is top view, and this is side view. Okay. So we have all the views. Now we'll try to understand the front view. So this is, in this boiler, we have different parts. As when we compare to the simple vertical boiler, most of the parts are very common between any type of boiler. Only the arrangement of the tank, water tank and steam tank will differ. Now see here, this is ash pit, and this is where we will burn the hot coal. Okay, so this is the water tank. So in this water tank, we have water. In the same tank, when the water boils, the steam will be generated. Okay, the steam can be taken out by this steam stop valve. Okay, and this is a safety valve which is used to protect the entire boiler structure when the pressure is very high, so that the safety valve will lift up and it will release the pressure. And here we have a furnace door. So we'll see the working. So first, at this place, the combustion of the coal is done, where the hot gases will be emitted. Now these hot gases will flow in this direction. We have arrow marks. In this direction, the hot gases will flow. While flowing, they will boil the water in the tank above. So this is water. So the boiling of the water will take place. Okay. So this is a long horizontal cylindrical structure. Okay. It is a cylindrical shell, because on the side view, we can see this is a cylindrical body. Okay. It is circular in shape. And in the front view, we can see it is rectangular. So this is a cylindrical shell structure inside which water is present. So the hot gases will boil the water in the shell and steam is generated. This steam can be used. So the hot gases, after heating the water, they will come here in this direction. Okay. they will come in this direction, and out from where it will enter into a smoke box or a chamber where the hot gases will be filtered and they are left into the atmosphere. Okay, and in the top view we can see the same thing. So here the combustion is takes place, and we have two chambers. One chamber on this side where the hot gases will flow, and another chamber is here. And after that, they will enter into a chimney. Okay, from where they will be entered into the atmosphere. Okay, the chimney is the unit which will remove the hot gases from whatever the hot gases that are present inside the closed chamber of the boiler. Okay, so this is chimney. So by this we can understand the working of any boiler. Any boiler, the working is same because of the arrangement of the water tube or water tank and the arrangement of the coal furnace, okay, etc. Based on these, different types will have different names. Okay, the basic working is same, where we will take coal. This coal is burnt. This heat is used to boil water, and we will produce steam. Okay, now remember, in Lancashire boiler we have a horizontal tank, and the heat will be produced by the combustion of the coal, which is passed through the closed chamber. Okay, when we have a horizontal tube, this horizontal tube is the combustion takes place. The generation of the steam will takes place inside the horizontal tube, and the hot gases will be escaped through the chimney. Now let us see what are the features of this Lancashire boiler. So it is a horizontal cylindrical shell type boiler. We have a long horizontal cylinder inside which we have water, and it is a fire tube boiler, where in the diagram we can see the hot gases are being flown through a closed tube. So this is a fire tube boiler. Water is stable here inside the tank. Only part that is moving is hot gases from the combustion. And third point is, it is placed over a brickwork, and this creates several channels for flow of the hot flue gases. So in the picture we can see there is completely brick lining is there. Everywhere we see there is a brick lining. And in fact, we have created the fire tube also with bricks. So that is why it is well insulated. The hot gases will not escape into anywhere. They have to move in a direction to boil the water, and from there they have to escape into the atmosphere. So that is another feature of this Lancashire boiler. The fire tubes are slightly conical at the rear end for increasing the velocity of the hot flue gases. So in the picture we can see the fire tubes are, the shape of the fire tube is like this. See here, at this point the tube in which the hot gases are flowing, the dimension or the diameter of this tube is reduced. See here, they are converted into conical shape. Okay, so what happens because of this? The velocity of the hot gases will increase. The velocity will be more because of this decreased cross-sectional area. Okay, so this is another feature. And after that, dampers are placed on each side of the regulating airflow. So we have dampers which will control the airflow into the furnace and out of the furnace. And then a manhole is provided at the top and bottom of the shells, and it is used to clean the boiler. Okay, anyway, in any boiler we have to have a manhole because for cleaning purpose. Why do we want to clean a boiler? So we have seen all the features. Now we'll discuss why do we need a manhole for a boiler? Why it needs cleaning? So here there are two things which we are using. One is water, another one is coal. So water has many types of carbonates that are related to sodium carbonates and etc. So these are commonly called as salts present in the water. Because of these salts, the hardness will be more. Okay, so more the salts, more the hardness. So what happens is, when the water is boiled, these salts present inside the water, they will be separated and they will form as a layer on the inside structure of the boiler. So this is called scaling. the scaling formation will be seen on the inside layer of the boiler. This has to be cleaned, otherwise it may lead to corrosion of the boiler structure. Okay, because we are talking about the steam. When the water is inside the water tank, when it is boiled, steam will be separated and these salts will be formed as a layer on the surface. So this process is called scaling, and this scaling has to be removed. So that is why the boiler structures are provided with manholes where a person can go inside and remove the scales that are present on the surface of the boiler. And after that, we use coal, because of which we may see the formation of coke formation on the internal surface of the furnace. We will see the formation of dark colored matter. So this also has to be removed, otherwise it may lead to more and more heat loss. Okay, so for these two cleaning purposes, we have manholes that are provided at different places in the boiler. One manhole will be provided at the top of the boiler, that is where the water tank is present, and another manhole is present at the bottom near the furnace, where we have to remove the carbon particles that are present inside the furnace structure. Now let us see what are the advantages of using this Lancashire boiler. So this boiler has an efficiency of 80 to 90%. This have very high thermal efficiency, because we have entire thing insulated with brick lining. So this will have maximum efficiency, and this is very easy to operate, easy to maintain, because we have different manholes and it is very well planned structure. Okay, the boiler, it generates a large amount of steam and more reliable. So this is the steam boiler which produces more amount of steam when compared to the other types of boilers, and it is more reliable. So it can produce steam at a very high rate, and low electric consumption due to natural circulation. Here natural circulation of the hot flue gases will takes place, and the natural circulation of the water inside the tank, because the water is not moving anywhere, there is no circulation required. So it is naturally circulated, so low electricity is required. If you want to use some kind of forced circulation, we should have some pump which will run on electricity. So here there are no pumps. So we'll see some of the disadvantages of Lancashire boiler. This is a low pressure type boiler, so it cannot produce high pressure steam. Okay, so the pressure inside this boiler is very less, but the quantity of the steam is more. It can produce more steam, but the pressure is somewhat less than the other boilers. Hard to maintain due to the brickwork, because of the brick lining present in the entire boiler structure. So going into this brick line is very hard, because the bricks the maintenance is very hard when the bricks are present inside the boiler. So it has limited grate area due to small diameter of the flue tubes. So in this furnace, we have a very small area where we can make the combustion of the coal. Okay, the combustion chamber is very small here. Okay, steam production rate is low, about 9,000 kg per hour. So due to the enormous size of this boiler, even though it can produce a very low quantity, that is 9,000 kilograms of steam per hour, and corrosion may occur in water legs. So we know whenever there is water, there is corrosion. Okay, corrosion is very dangerous for any boiler structure. So corrosion may occur in this boiler. Now let us see some of the applications. It is used to drive steam turbines, locomotives and marines. So steam turbines are nothing but the thermal power plants, where we will use steam for running of the thermal power plant. Like steam turbine will be rotated with the help of the steam coming out of this boiler. And we have locomotive engines, where we will use this same kind of boiler only. So this is the best example for this Lancashire boiler. In older times, we have steam engines. And marines. Marines means they can be used in ships and submarines. In olden days, they used to use this kind of Lancashire boilers inside the ships for running the ship. Okay, to move the ship from one place to another place, they will use this kind of boiler. Now they are using mostly diesel engines. It is used in various industries like paper industry, textile industry, sugar and tire industry. So these are the applications where the Lancashire boiler is used. Here we can produce large amount of steam more reliably, but the pressure of the steam is very less when compared to other boilers. Now we'll see the working of Babcock and Wilcox boiler. Now this is a Babcock and Wilcox boiler in which we can see there are different structures. Okay. See here, we know already the parts are already known here. Now we'll see where the combustion takes place. So this is the place where the combustion of the coal takes place. The hot gases will be emitted, and these are all the tubes, water tubes, inside which the water will be flowing. Okay. So above which we have a closed tank, cylindrical tank, inside which we have water. So now let us see what is happening. When the coal is combusted here, it will produce hot gases. These hot gases will flow in this direction. Okay. In this direction, the hot gases will flow. Now inside these tubes, we have water flowing, and this water, while flowing through these pipes, it will be converted into steam. Now the steam will be collected. Now all the pipes, the water will be flowing in this direction. Okay. Now when they start from here and when they come to the end of the tube, the steam will be produced. Now the steam will be collected in this tank. So this is the steam. So this is a water tube boiler, and it is a closed circulation boiler where we will make the combustion of the coal inside a closed chamber. Okay. Now the steam that is generated here, it can be used for in many other applications. Okay. Apart from that, we have a superheater here. Okay. This is the key thing which is different from other boilers. Now this superheater will work in a different way. Now the steam which is generated in these tubes will be once again sent into this superheater for further heating. Okay. Generally the water, when it is heated, it will be converted into steam. Now this steam will have some moisture particles inside. Okay. Now when this steam is further heated, we will get superheated steam. Superheated steam. Now what happens because of the superheated steam? We will remove those moisture particles. All moisture particles will be completely converted into gas, like that is steam. Okay. So the superheater is the added extra add-on for this Babcock and Wilcox boiler. Remaining thing is same as the working of previous boilers. Now we'll see what are the features. It is a horizontal, stationary and straight. It is externally fired. Natural circulation is done. The water inside the water tube will be flowed with the help of natural circulation, because we can see in this picture the 5 water tubes are inclined. Because of the inclination, the water will flow automatically due to gravity. And this is a water tube boiler. We know water is flowing inside the closed tubes where they are subjected to hot gases. The steam pressure is about 71 bars, and the steam production rate is about 2000 to 40,000 kg per hour, depending on the size of the boiler. So the same kind of arrangement can be done for a smaller size and also bigger size, depending on the size of the boiler we have chosen. The steam rate may go up to 40,000 kg per hour, and the efficiency is about 60 to 80%. So 60 to 80% efficiency will be attained in this type of boiler. Now some of the features are, it has 3 main parts: water drum, steam drum and water tubes. So water drum is the structure inside which we have water that is stored, and steam drum, that is where steam is collected, and we have water tubes. Now we'll see these 3 parts in the picture. So here, this is water drum where we will have water. Now this water, it will enter into the tubes. To these tubes, the water will enter. Now when the water is flowing through these tubes, what happens? The water will be converted into steam. The steam will be sent again into the superheater, from where it is taken back into the steam chamber. Now this is steam chamber. Okay. We have same tank, but it's separated by some kind of arrangement. We have water on the left side, and we will collect steam on the right side. And we have water tubes here, which will make the water boil. Now, ninth point is two drums are connected with uptake and downtake header. As we have said now, there are two drums which are connected. They will be connected, but they are not. They will be separated with the help of a separator. And water tubes are connected to the headers are inclined at 15 degrees to the horizontal. Now we can see here the water tubes are inclined. Now this angle is 15 degrees. So due to the inclination, we can get natural circulation of the water. And furnace is arranged below the header. We have the furnace which is arranged here. So this is the furnace area where we will burn the coal. And dampers are fitted at the back of the boiler to regulate the draught. Okay. Now, what are the dampers? Dampers are the devices which will which will control the flow of the steam. Okay. So they will control the steam where the hot gases that are coming out of the coal, they are also controlled by these dampers. Okay. Now we have seen all the features of this boiler. So far in this lecture we have seen three types of boilers. First one is Cochrane boiler. Second one is Lancashire boiler. And after that we have seen Babcock boiler. Babcock and Wilcox boiler. So these are the different types of boilers and their working. We'll meet in the next lecture.
Like, share and subscribe. Hit the bell icon for more updates.